Get another dance. I'm leaving. Vanessa. I gotta go.
Hey,
Hey,
how are you?
I'm good. How are you?
I'm good.
Okay, before we start, can we talk about because I'm taking my MCAT in like 13 days, I think. So can we
Yes.
talk about like a schedule? Because I want to have something consistent.
Mm-hmm.
Um, yeah, so let me see. Okay, so I have this stupid course that I have to go to. It's this week, it's Monday, Tuesday. It's every day except for Friday. And it's from 1 to 3. So outside of that, I can meet anytime.
You said it's Monday, Tuesday?
No, Monday through Thursday, but this week is the last week for that class.
Got it. And
Yeah,
it's
so
MCAT class or gross anatomy or whatever?
it's MCAT, but I don't even pay attention in it because it's not. So the Kaplan one, our program director told us we didn't have to go anymore.
Yeah.
So I haven't been to that one because that used to be from 9 to 12, but we have a faculty led one. But it's pointless because they try to teach us like concepts and stuff, and I'm like, it's too late in the game for that. Like, this isn't helping. So,
Yeah.
um, but after the 30th, after this week, I won't have those classes anymore.
Yeah.
So yeah, I'm taking Bullen 4 next week. I took Bullen 3 this weekend, and I got a 503.
Oh.
So it was better than the last time.
Mm-hmm.
Not the last full length, because last full length I made a 504, but that was because of my cars, but my cars went down again.
Mm-hmm.
Or else I could have got a 506 if I had the same car score.
Mm-hmm.
But it's better than the full length 3 I took last time when I was studying.
Mm-hmm.
So yeah. Yeah. So what days, like what's your schedule looking like?
I'm pretty much free. I mean, I can schedule anyone in at any time.
Okay, so Wednesday I might do sample test. So we
Why do
can
you
meet
think
again.
these eye drops are this color?
It got some type of pigment or something.
Yep.
Okay.
And what do pigments have?
It started with a C.
Yep.
Chromophore?
Well, they are chromophores, but what type of
Carrot?
something? Those are the syllables.
That's a lot of something. I don't even know.
Something gated.
Conjugated
Mm-hmm.
ring system.
Conjugated double bonds.
Conjugated double bonds. Yeah. Okay.
So this has vitamin B12,
Mhm.
which is cyanocobalamin, and yeah, has lots of conjugated pi double bonds in them.
Mhm. That's cool. So, yeah, this is the highest I got on a CP section, I think.
Wow, that's good.
A CP section was pretty good. Cars went down again.
Mm-hmm.
BB and yeah. So I have a one note with the questions that I want to go over. It's not that many though.
Yeah, I was trying to figure out how to get that OneNote to you.
Yeah, because I never received the link for it.
Yeah, so I don't. So did you try opening it up through the app? Like here, see if you can open the OneNote app, and if you can do it through there, because that's how I generally, add them.
Yeah, that's what I did. I went to the.
See if you can share your screen for the OneNote.
Okay, because I was doing that on my other laptop, but I have it here too.
Okay.
is it?
Hindgut.
I know, right?
Okay, so let's see.
Here,
Click
and I'll
that,
put.
and then click Add Notebook. Oh yeah, go back to that where it said hide note. Click on like on your notebook.
Here?
Yeah, and then see where on the bottom it says Add Notebook.
Yeah.
Yeah, hit that.
Mhm. That's what I pressed.
What? Why doesn't anything come up?
I don't know, cause I thought
Yeah.
that's what I was trying to do. Um, last time I thought it would show up here what you
Do
shared,
you,
but
do you have a different version of OneNote?
no.
Because this is the one that comes with the computer. There's like an. All right, so let's see. All right. What if you hit that share button on the top right?
You said here?
On the top right.
Oh, the share button.
Yeah.
Ugh.
So that's like okay. So let's see if you can put in my email because that's how I've been sharing it with you.
Okay, I think.
Because if I can't share mine with you, you can share yours, and we can see if that can work. So type
Sure.
in here. I'll put it in the chat. It's just my first name, last name, 16@gmail.com. Oh, just first. Sorry. First letter. Yeah. Yep. Oh, outside of my organization. Outside of your organization. So let's see. All right, that might be something. See if anything came up in your spam box, because that's how I sent it too. And if you're not allowed to send outside of your organization,
Let's see. Oh, here it is.
Oh, did
It
you
was
find?
in junk.
You found it in the spam?
Yep, I never checked it.
Ah, got it.
Okay, are you gonna open? Why is it acting stupid? Let me do it on here because this laptop, they got so much stuff locked up.
Mm-hmm.
I hate Outlook sometimes. Oh, there it is. I wonder if I can like put open on OneNote or something.
Oh, so what happens in that email? Let me see it.
So when I open it, it opens as the link.
Yeah, in the browser. So yeah, let me see that. Let me see the email. Oh, do you have it so it just is sharing the window and not the screen?
Yeah.
Got it.
Yeah.
Yeah, okay. All right. So that caution, this email came from outside. All right, that's why.
Yeah.
Okay. So, yeah. So
When I press open, it comes up like this.
yeah, in the browser. So, this is what you can do. Oh, yeah. So it's on a OneDrive. All right. So it's on the OneDrive, which is basically like the cloud service that comes with the OneNote.
Mm-hmm.
It's like Microsoft's version essentially.
So if I go back to the notebooks from earlier and add notebook.
So, let's see what can be done here. So, look, for instance, let me share my screen real quick.
Okay.
Alright, you see it? My screen over here? My OneNote?
Oh, now I can, yeah.
So, here, when you do this, right, I have more notebooks here. I click that, and then these are all the notebooks that are in my OneDrive. You can see it says not seeing all your notebooks, learn more. And this is moving your notebooks from your computer to the cloud, and vice versa. Okay, so let's see. In the documents or my documents folder of the hard drive, so that should be where it is stored. Let's see. All right, OneNote notebooks. Got it. So see in your documents folder, there should be a folder that says OneNote notebooks.
Let's see.
And then you can also add an account, which would be, you know, my OneNote account or OneDrive account, which for you would be, you know, the thing or whatever.
Oh my god, let me try to do it again on the other laptop.
Because you see, I shared it with you over here.
Yeah. I'm trying to see if I can do it on. I'm gonna put not junk. Okay.
Okay, you can try this also. See on my screen over here, this like dot
Where?
over here.
Mm-hmm.
Click there, click settings. You have a bunch of things you can do. Hit accounts, and I can see this is the account that I've added to OneNote.
Mm-hmm.
So that's basically, so like for you, see if you're signed into your like account through there.
Mm-hmm. Yeah, I'm signed in through.
Okay.
I think.
What about for options? Do you have like sync notebooks automatically?
So you said it should open in folders. So let me try. I'm in documents. When I go to documents, it should be saved under what now?
Oh, OneNote notebooks. That should be the ones that are saved on your computer, so the ones that you already have.
Yeah.
Do you see anything in that folder?
I don't even have a OneNote notebooks folder.
So in your Windows, the left part of your taskbar, if you can see like on my screen, like this is where you go over here where it says documents. Hit that, and you'll see whatever's saved in your My Documents. So you know I have a bunch of stuff saved, and then OneNote notebooks, and some should be there perhaps.
I don't know. I don't know if it's just me that don't know how to do it, or if it's my computer. Try one more time. I wonder if I can save this. No.
Yeah, I think since you're using like your educational institution's email, they put some an extra level of security. Like I'm looking at an email from your friend to Mia, and it says, you know, it's like the email that I sent her. It says, "Caution, this email." Yeah, you got it.
I think so. Let's see.
Danced with.
Don't make me laugh, I've been trying all night. You were shaking your ass for like half. But I
Feel nice.
give me a chance all evening.
What?
Do I get another dance?
I'm leaving.
Vanessa,
I gotta go.
don't walk away from us
I
tonight.
don't need anything tonight. I can find my way
Keep running
home
away from
without you.
It's creating a new notebook. It's taking forever, but let me go back.
Okay, we can figure this out after then.
Yeah,
All right.
I think I
So.
got it though, actually.
Mm-hmm.
Hold on. Last thing I am. I basically have to press print and save it as. Okay. Oh, it's saved as a printout. Okay, forget it.
Yeah. Yeah, we'll try to figure that out later. So, let's get right to it.
Okay, so where is share screen? Okay. So it was a few. Let me see what questions I have received.
Yeah, that's a really good CP score.
Thanks.
Yep.
Okay, no, to this one. What was the question? Okay. What number was this? This was number.
Do you study together with your friend?
Yeah, sometimes. Like we review.
Mm-hmm.
Today we were together earlier reviewing the full length.
Yeah, I tutor her right after you.
Yep.
Mm-hmm.
Her and my friend Sam.
Oh yeah, yeah. I'm gonna tutor him sometime this week.
Yeah. This one. Okay. So for this one, I know
Hydroxamic
this stuff
acid.
because I was thinking of the.
So let's see in the passage what it what it looks. It seems like it looks like. Let's see.
Oh, it said
Okay,
acetylation.
compound 2 produces the acid. So if you look at compound 2, let's think how can you make that into an acid, right?
Mm-hmm.
So, all right, let's look at the choices. Okay. So, let's see if you can not hit like control minus. It'll like zoom out a bit. So I just want to, so I can see like the compound 2 as well. So okay, so, all right, now compound 2, let's see. So, it even tells you. So it says acetylation, right?
Mm-hmm.
So what's acetylation? What's an acetyl group?
That's what I had to look up today, and I realized that acetyl group it's like a ketone.
Kinda, yeah. So
But
definitely
why is it
know that
called
group.
not
Definitely know
just
the acetyl group. It's essentially it's a it's a carbonyl, it's a C double bonded to an O.
Mm-hmm.
And okay, so acetylation of the hydroxylamine nitrogen. Show me where that one is.
Hmm?
The hydroxylamine nitrogen.
Hydroxylamine. This one?
Yeah. Why is it that one?
Because that's the hydroxyl group.
Good. So that leaves, right? And it
Mm-hmm.
gets acetylated, so that's where it's going to add.
Got you. Okay.
And it seems like the rest of the stuff, they just make it R, so we don't have to worry too much about that.
So why did they add this OH to the N group right here?
Okay, because where it's okay, so it seems like let's see. Subsequent. Okay, so SID A is some type of oxygenase. It is okay. It works on the substrate, which is compound 1. Seems to be something ornithine, and then whatever it turns into compound 2, and compound 2 gets acetylated at that hydroxylamine nitrogen and produces a hydroxamic acid, which is used by the organism to complex iron. All right. me see if I see it mentioned anywhere else. All right, so let's see. So okay, since they're saying general structure, that's why they have R groups. So let's just, all right, so for instance, A, right? That's just, well.
You said that's what?
Oh, sorry, no. I was just saying A is pretty much just a, so okay, it won't be A because we're looking at compound 2, which has that, like, it has that OH group all the way on the right side. I mean, not the OH group, the, like, kind of like COOH all the way on the right, but, you know, the H is left.
Mm-hmm.
And then it's attached to, you know, that nitrogen that's on the bottom. That's, like, the basic structure of, like, you know, an amino acid, for instance. So that's, like, that's, like, the backbone. And it's attached to another amine. Okay. General structure of hydroxamic acid. Acetylation of the hydroxylamine nitrogen produces... So, okay. You know what?
Oh, so they didn't really take off the OH. They just added the acetyl group on the other side.
Yeah, that's
the
weird.
OH
Let me
is
check
there.
something out. Let me see if I even know what I'm talking about with acetylation. Yeah, acetylation is all right. So that's what I thought. Okay. All right. Acetylation. Okay, that's what I thought. Okay. Okay. So, all right. Let me look at the choices over here. Because acetylation seems to happen to the amine.
Mm-hmm.
So, okay. Let me see like all the choices, like D included. Okay. So, all right. The first one just seems like that. It's just an amide. Like A looks it. So A and C both have an amide group.
Mm-hmm.
Do you remember amides?
Yeah. And that's why I was confused because I was thinking hydroxylamine. So I chose D
Mm-hmm.
because I know that's an amine, not an amide.
Yeah, that's a hydroxylamine, correct.
Yeah.
But it's no longer an amide because an amide is the So like, yeah, which one? So what's the amide group?
This right here, right here.
Good. Do you see another one?
Right here.
Good.
This is
see-
an S.
Yeah, good. All right, good. So, all right. So we have two. Okay, so let's see. What the hell? Okay. Says, answer this question is C because hydroxamic acid was described in the passage as resulting from the acetylation, which is an attachment of, you know, the carbonyl bond bound to, like, you know, an R whatever group of the hydroxylamine nitrogen, which is NHOH, so it's the right one. Okay, so I guess we don't care about the rest of the stuff. We just care about that hydroxylamine no longer being an amine, but having an OH, not an OH, a carbonyl bond added to it. So, okay, you know what? I see what's going on. So, I thought that acetylation meant that the hydroxylamine disappears. But it doesn't. It stays there, and the other thing that it's attached to gets acetylated. So, if you go back to compound 2 above, so that, you know, show me where that nitrogen bound, yeah, that one. So basically, it gets acetylated, and I believe it breaks away from that rest of that compound.
Yeah, the OH stays though.
Yeah, the OH stays, and then but that right part of that backbone seems to disappear, and that is where the acetylation is.
Okay.
Like to the right side of that NH group. Yeah, like that backbone seems to disappear, and that's where the acetyl group adds to.
Gotcha.
Which I'm sorry, it does not disappear, but they just wrote R to make to as a general term for all that other stuff. But yeah, no, that's pretty tricky because I would have thought it would have been replaced completely. And yeah, I'm looking at some other examples of acetylation.
Okay.
Okay.
That was pretty much it for CP, honestly. It wasn't too many that I missed. And I went over the ones I missed, but for BB,
Yeah.
I always have more questions for BB. Let me see which one.
That first one looks like a little like physics related.
It is. It definitely was. Hold on. Where is the question? Okay. Number. Dang it, I keep cropping out the 24, I think.
So I like that the ones that you spent more time on, you flag. That's good.
Oh, yeah. I flag a lot now.
Yep. That's the way.
And I saw that most of the ones I got wrong for BB was because I changed my answer. Okay. So this one, oh, never mind. We figured it out. Is it because this is a prokaryote, so it wouldn't be alternately spliced?
Yeah. So tell me about alternative splicing.
That's when you are taking out the introns and the exons, you're gluing them together.
Yeah, and but so taking out the introns is a splicing part. The alternative part means that the exons could be put together in different orders.
Oh yeah.
So
Isoforms.
So like yeah, exon 1, 2, and 3. Let's say you have 4 exons. You can have a version that's like exon 1, 2, and 3, exon 3 and 2, exon mobile, exon Valdez.
Okay.
Those are jokes.
Okay.
It's an oil company.
And
That's Exxon Mobil.
Oh, Exxon Mobil, yes.
And Exxon Valdez was a big disaster where they were in like the 90s when they had a major oil.
That's crazy. Let me see which one.
Yeah, did it tell you how they remove? Oh yeah, no, but this is kind of related to the Venturi effect. So like, for a big oil fire, they use dynamite.
What about dynamite?
They use dynamite to put out an oil fire. Like, let's say an oil rig, there's a massive fire. Tell me why. Why would they use dynamite?
I was confused why they would use dynamite. 'Cause when dynamite, I hear like boom, like.
Yeah, so there's a difference between.
Oil.
So like generally speaking, when we think of bombs, we think of boom, it makes a fire, right? But a high explosive, it creates more damage due to supersonic waves. So that's why they use dynamite to break apart rocks and things like that when they do demolition.
Well, why would they use that on oil?
So think about it. So in order for something to be burning, right, what type of reaction is it?
Combustion?
Correct. And what are the reactants in a combustion reaction?
I know you produce heat.
Sure.
Right? I don't know what the reactants are.
So cellular respiration is actually an example of combustion.
Oh, because of the ATP synthase?
Nope.
No.
So anything that's a combustion reaction involves some type of organic molecule. So cellular respiration, the organic molecule is glucose. Okay. In some other type of thing, it could be like octane. Right? Like a fuel. Like a fuel? And so oxygen must be needed, right?
Mm-hmm.
So if you detonate some high explosive that basically causes everything to be pushed away, right?
Yeah.
So it pushes away all the oxygen. So that combustion reaction no longer has any fuel. Because oxygen is the fuel.
Oh, so that's why they use that.
Yeah, like if you ever have like any like a candle, right, with like a thing on like a glass like whatever, try like putting like a glass like plate over it.
Okay.
What do you think will happen to that flame?
It's gonna bust.
No.
You said right?
No. So if you just cover it, that means that the flame will go out because it's going to use up all the oxygen and
Oh,
no more is going
I
to
thought you were asking what would happen to a plate.
Oh, sorry. What if you like have like so here like this, right? So there's like a candle inside, and if I light the candle, that's out. But if I light the candle, right, it's basically taking in oxygen and combusting, right? But if you cover it, I'm suffocating it essentially. It's going to use up all the oxygen, and then there's not going to be enough, and the flame's going to go out.
Under oxidative stress.
No, just from not having any more oxygen in it.
Got you. Okay.
And when you blow the candle out, you're basically doing the thing that dynamite would do, except it'll blow it like much faster.
But we blow out CO2.
Yeah.
But CO2 has oxygen. Okay.
Oh, no. So CO2 is what it needs. I'm sorry, so oxygen is what it needs to burn, and it gives off CO2. But in this part, like, it doesn't necessarily matter what we're blowing into it. Like, if you blow something, like, think about, like, when you blow out a candle, you blow it out so fast that it goes out.
Makes sense.
Yeah. There's, like, I don't know. There's, like, a really good movie called The Sorcerer, which has nothing to do with sorcery. And, yeah, it's basically, the plot of it is, generally speaking, it's like there's an oil rig that's on fire, and they need people to transport through land a lot of dynamite, which is extremely unstable because of nitroglycerin. And so they basically have people who are like running from the law to do something like that because they have no choice. So they have like this Palestinian guy. They have like, yeah. Anyway, let's see this one. So, this is what you're talking about, oxidative stress.
Yeah. So when you have fatty acid oxidation,
Yes.
that's that's under starvation. So is that when you don't have? It's like more so anaerobic.
Fatty acid. So like, think of that word, oxidation, right? So it's going to need oxygen. So it's not going to be particularly anaerobic like glycolysis would be. But
You said like what would be?
Oh, like glycolysis, for example. Glycolysis, doesn't need oxygen. That can be anaerobic. So oxidative stress is essentially when you have some type of free radical. That's why there's things like antioxidants, right? There's probably something written ROS over here that says, reactive oxygen species.
Yeah.
Yeah. So that's kind of, oxidative stress. Beta oxidation, remember how that works?
Yeah, so I know you are cleaving it, you're making acetyl-CoA, you're making, I know the products are like NADH, FADH too.
Oh yeah, those are like, the electron carrier aspects of it. Yeah. But yeah, the products will be, cut apart by twos to make the acetyl-CoAs. And the final 2-carbon product is just going to be the acyl-CoA.
Yeah.
Yes. Yeah. Did you know that camels, you know how they say camels have their hump? That's like just all fat. So why do they say camels can make their own water? Because when you break down fats, you make water. Killer whales, for instance, they don't actually drink the seawater. They eat really fat things like what are they called? Those like walruses and stuff. And they eat their fat, and when you break down fats, you release water.
Got you.
So let's look at this one. If HDAC inhibition by beta OHB is a physiological response in living animals, the information in the passage indicates that it is likely to occur when. So let's see. So, look for HDAC. It seems like it is. Oh, that's funny. Like when I looked up acetylation, I see HATs.
Oh.
They're the ones that acetyltransferase, so they transfer, an acetyl group, right?
Yeah, increasing transcription.
And so butyrate, so like the ketogenic stuff, or like that diet, ketogenic diet. Yeah, so ketogenic diet essentially like makes these ketones. Butyrate is an example. So they say it's a product of bacterial anaerobic fermentation, and they're talking about it as being a regulator of gene expression. And so, for example, exogenous butyrate is used in clinical studies to stimulate fetal hemoglobin expression in individuals with sickle cell anemia. Okay, butyrate exerts its function by inhibiting histone deacetylases. That's the HDAC, which counters the effect of histone acetyltransferases, HATs, in controlling chromatin structure in histone and non-histone proteins. So they modify basic residues on target proteins, right? So what would be examples of the basic residues?
Lysine, arginine, histidine.
Correct. All right, butyrate is structurally related to beta hydroxybutyrate. That's the B beta OHB. And that's the major source of energy for mammals during prolonged exercise or starvation. So you know how like the brain can only use glucose, but it can also use the ketone bodies?
So brain can use ketone bodies as well?
Yeah, and that's all. It can only use glucose or ketone bodies.
Okay.
So, now to determine whether beta hydroxybutyrate may also have HDAC inhibitor activity, they treated cells with different concentrations of beta hydroxybutyrate. After 8 hours of that exposure, histone acetylation levels were measured, and it seems so they did it with the canine thing, which means the lysine is at 9, at the 9th position. The K14 means that it's at the 14th position. And then, what is this 40 thing? Okay, so results are shown. Oh, no. The antibody to... Okay, that's a different one. AC tub. Okay, that tubulin, K440, only binds to acetylated tubulin. Okay? So, the other ones are for, antibodies. And the tub one is for acetylated tubulin. So it seems like, as we increase the concentration of beta hydroxy butyrate, the amount of protein that gets acetylated, that gets basically, so they're trying to see if beta hydroxybutyrate can, if it inhibits HDAC, what would happen to the acetylation?
It would increase it, right?
Correct. So, and you kind of see that. You see basically for the lysine on the 9th position, it goes up. 14th position goes up a little bit less. And then the antibody for the tubulin, changes the least.
Okay.
All right. Now, they also identified...
On the 14th position, why did it only go up a little bit?
I don't know. What do you think? Maybe because it's deeper and harder to reach. Could be, right? Because we're dealing with basically
histones.
Yeah. So and then let's see. Researchers also identify the role for it against oxidative stress, which can result in carbonyl derivatives that are formed by direct metal-catalyzed oxidative attack on the amino side chains of proline, arginine, lysine, and threonine. And then some other stuff. Paraquat. Okay. Results show that protein carbonylation was suppressed in mice receiving beta-hydroxybutyrate. That would have been a good one to highlight as well. All right, so let's check out the question. Okay, if HDAC inhibition by beta-hydroxybutyrate is a physiological response in living animals, the information in the passage indicates it's likely to occur when... So they're saying that it's likely to occur during, the formation of the things of sorry. If you go to the top paragraph one more time. So they're saying that okay, so it happens during prolonged exercise or starvation, right?
So that's why I thought gluconeogenesis.
Let's see. Prolonged exercise or starvation. So, okay. Prolonged exercise or starvation, right? So, yeah, there could be some gluconeogenesis being done, but that's when, your body starts to break down the fats as well. Because when your body starts breaking stuff down, first it's going to use whatever glucose is in your bloodstream, right?
Mm-hmm.
And then I suppose it'll release glucagon, which will start, the gluconeogenic pathway to provide your body with some more glucose. But as it's doing that, it's going to start breaking down the other things in your body, like fat.
What's going to start breaking down?
Oh, the other sources of energy in your body.
Mm-hmm.
So, like, for instance, it'll start breaking down, like, the glycogen, right?
Mm-hmm.
The fat, and some protein.
You said what does that?
Oh, sorry. Just if you enter into, like, a fasting state, or if you exercise for a long period of time, like, you probably see it, like, when you're on a treadmill or whatever, and your heart rate reaches a certain point, and it says fat burning.
Uh-huh.
Yeah, so that's basically... So when your body's running out of, like, the initial, like, glucose, it's going to start breaking down fats and things like that.
This was a stupid question because I feel like it could have been A or C. They weren't.
Oh, yeah. All right, let me see the questions again. All right, so let's see. You said A or C. Okay. So pentose phosphate thing, that's, making essentially pentoses for, like, nucleotides and things like that. Cori cycle, I think that's just in, that might be in plants, or it might be confusing it with Calvin cycle. But, let's see. So between A and C, right?
Mm-hmm.
Okay. Let's see. Gluconeogenesis. That is... Oh, wait. Isn't gluconeogenesis the formation of glucose from, like, those, like, three things? Like,
It said it occurs beyond around 8 hours of fasting when liver glycogen stores start to deplete and an alternative source of glucose is required.
Yeah, so I think it comes from...
It makes it under starvation.
Yeah, it comes from Oh, here we go. So gluconeogenesis comes from 3-carbon precursors. So lactate, alanine, and glycerol.
Yeah, I remember that from your Anki deck.
Oh yeah. So okay, that's something that is a way of essentially making more glucose that you need. But I'm thinking of the breakdown of glycogen. I believe that's glycogenolysis.
Yeah.
So basically, like, that will happen. Let's see.
This question is stupid.
Let me see.
I guess they wanted to know if in longer periods of fasting.
I see. Yeah. Okay. Glycogenolysis. Okay. Okay. Now they're saying. Okay, so they're saying for the beta hydroxy butyrate, how does that form, right? So let's see. Fasting leads to glycogen breakdown and gluconeogenesis, so you're correct on that. Then continued fasting leads to the production of ketone bodies by sustained fatty acid oxidation. So I know that when I tried the ketogenic diet, it takes a long time for your body to start breaking down ketones.
Mm-hmm.
And beta hydroxybutyrate is a component of ketone bodies. So essentially, the levels of beta hydroxybutyrate are going to be elevated when there's a sustained fatty acid oxidation. So the formation of ketone bodies occur when essentially so it happens in the mitochondrial matrix of the liver. Okay, so in my notes I have it right after fatty acid oxidation, right? Mm-hmm. So fatty acid oxidation happens. So fatty acids are broken down into glycerol and acetyl-CoA. Acetyl-CoA can enter into the TCA cycle, right? Mm-hmm. And this happens in the mitochondrial matrix of adipose tissue. Now in the mitochondrial matrix of the liver, the acetyl-CoA is an easily transportable form of a fatty acid. Like, it's no longer a fatty acid because a fatty acid breaks down into glycerol and acetyl-CoA. But, you can think of acetyl-CoA as being like, something that is formed from the breaking down of fatty acids. So it's a form of that kind of, like, it's a product of that can move around. And two CoAs condense, and another CoA can be added to give you acetoacetate and acetyl-CoA. The acetyl-CoA can be decarboxylated into acetone. The acetoacetate can be reduced into beta hydroxybutyrate. So this is some biochemical pathway stuff. Let me see if I can open up the biochem book that I use. Okay. So
I was also trying to find the kidney notes that you made for me last time, but I couldn't find it in one note.
Yeah, it's in the older one.
Yeah, that's the one I'm talking about. I looked in there, I didn't see it.
Yeah. So, okay, I see this right now. So, okay, let me see for a sec. All right, so you remember how I said that, in beta oxidation, it breaks it down into acetyl-CoAs? Mm-hmm. All right, that shortened, and the last thing left is a fatty acyl-CoA. So that last thing that's left, that fatty acyl-CoA, can go through another beta oxidation cycle, and when this happens, it basically produces. Wait one sec. Hold on. Oh, cool. It goes even into vitamin B12. Okay. I'm trying to go to the part where, because it's in the same thing. Okay. Got it. Okay. So, most of the acetyl-CoA produced by the oxidation of fatty acids in liver mitochondria undergoes further oxidation in the TCA cycle, so that I have that in my notes, but I didn't connect it to this. Some of this acetyl-CoA is converted into three important metabolites: acetone, acetoacetate, and beta hydroxybutyrate. This is called ketogenesis. And these three metabolites are traditionally known as ketone bodies. Despite the fact that beta-hydroxybutyrate does not contain a ketone function, they are synthesized primarily in the liver and are important sources of fuel and energy for basically, everything, including the brain. However, during periods of starvation, ketone bodies may be the major source of energy for the brain. And this occurs, mitochondrial matrix, and got it. So this happens with the same enzyme that carries out one of the reactions in beta oxidation, but here it runs in the reverse. So, so let's see. I want to add this to a OneNote, but I don't know. I'll add it and then I'll figure out a way to get it to work for you. It does work for you, at least in the browser, right?
Mm-hmm.
Okay, so here I'm going to just copy and paste this over here. This is from a really good biochem book.
Okay. I'll go to the next question because
This even talks about hats and HDAC and stuff like that.
Mm-hmm.
But so for that one, let me just look at that one last time. So the key thing here for that question, the key thing here is just so I suppose it's after that, So the key thing here is to know just that that these ketone bodies are basically, they only kick in during prolonged exercise or starvation. So in those choices, you have the gluconeogenesis and the fatty acid oxidation.
Mm-hmm.
And fatty acid oxidation can be further oxidized into those ketone bodies. So generally speaking, for a ketogenic diet, they want you to eat a high amount of fats.
Okay,
so,
that makes sense.
Yeah, so I'll add some more stuff to metabolism.
Okay.
All right.
Let me go to the next. Oh, here it is. Okay, so I got this one right, but I had a question when looking at these graphs because when we're looking at the sigmoidal graphs with hemoglobin, when you shift to the right, that means, I know you said that right thing to do, so decrease in...
Yeah, this is a little different though, but it tells you that the rate of protein synthesis, right, is greater when it's at 45 degrees than when it is at 37 degrees, right?
Yes, that's what I was going to ask. The only reason I'm comparing it is because of when you're shifting to the left or right on a graph, usually if you're shifting to the left, does that mean increase?
So that's a general kind of thing for the oxygen hemoglobin dissociation curve.
I'm talking just for any graph, because for this one, the shift to the left was the correct answer.
Oh, okay. So in this case, there's no shift though. It's just because they're talking about rate, so we're just looking at the slope. So essentially, at 45 degrees, it's going to be a steeper slope.
Gotcha.
Whereas for the oxyhemoglobin dissociation, the slopes and everything are exactly the same. That's where there's a shift. But here, even if you do a shift, it's not going to be right because it's about the slope. It's about the steepness.
So when it's a steeper slope, it's occurring faster?
Yeah, because you're talking about the rate of protein synthesis, right?
Mm-hmm.
And they use a measure of radioactivity, which I suppose, which I assume means that if protein synthesis is, I assume that this radioactivity is a measure of protein synthesis?
Mm-hmm. It is.
Okay, so if it's a measure of protein synthesis, right, and we divide that by time, that would be a rate of protein synthesis, right?
Yeah.
So if it's a faster or a higher rate, its slope is going to be higher, therefore steeper.
Okay.
So yeah, so for this one, is the answer B? I don't know what D looks like, but
yeah, I chose B. Yeah.
Yeah, so you see how B has a steeper slope at 45 degrees Celsius.
Mhm.
Yeah, it's steeper than the one that's at 37.
Okay.
And yeah, so that will be that's how you will do that.
Okay. Messed up those, but I think
I always
this.
like stuff about neurotransmitters.
You said you what?
Oh, I always like stuff about neurotransmitters.
Oh yeah. This one wasn't too bad. Oh, here it is. So with osmosis, so I know with osmosis, it'll go from an air, from it's like diffusion, but with water. So
Yeah.
an area from high to low, but it's for the solute concentration.
Will
It
be the
goes
other way
to,
around.
huh?
Yeah, so high to low, high concentration of water to low concentration of water.
And
For the
solute is the opposite.
Yeah, because if it has a high salt concentration, it means that there's less water.
Water, so it wants to go there. So with this, when you have a reduced amount of plasma proteins, the way I was thinking about it was when you say osmotic pressure, is it if you have low pressure, if you have low water, that's low osmotic pressure?
Oh wait, so basically, if there's more osmosis, that's going to be happening, right? So like if the solute concentration is super high, osmosis is going to happen like crazy, right?
Yeah, but I'm trying to relate osmosis with the osmotic pressure.
Oh yeah, so osmotic pressure will go up with how much osmosis will happen. There's also like a formula for it, which is basically
I know it's like pi equals
yeah.
pi RT.
And it's
something
not
like
pi like pi. It doesn't actually
Yeah, I'm
mean
saying
pi.
pi just because of the sign.
Well, yeah, no, you're right. It is you know the letter pi. But yeah, for some reason they use that as to represent osmotic pressure.
Mm-hmm.
So okay, let's see. So basically, if there's reduced amounts of plasma proteins in the blood, that's a reduced amount of solute, right?
Mm-hmm.
And reduced amount of solute means less osmosis, right?
Mm-hmm.
And subsequently, or consequently, less osmotic pressure.
Got you.
So
Okay.
the osmotic pressure is going to decrease.
Okay, because that's how I thought about it. I just wanted to make sure my thinking process was right.
Mm-hmm.
Because for this one, I mean, I got it right, which as far as the osmotic pressure, but I mixed up the diarrhea and constipation. I knew it would increase the osmotic pressure if you have more unabsorbed fats in the intestines, because it will be more solute in the intestines. So the water would rush to that. The water would go to where there's a lot of solutes, right? Yep, because it's little water.
Mm-hmm. Yeah.
So I knew it would be increased, but I guess the whole diarrhea and stuff I forgot. But it made sense when I was reviewing it. Okay.
Yeah.
That's
This is like for.
yeah.
Mm-hmm.
Okay. So with kidneys,
Mm-hmm.
because in the OneNote, the old OneNote that you had for me,
Yes.
let me see. There's a section for kidneys, but there's not. I could have sworn you wrote it out for me where it was like the renin angiotensin pathway, angiotensin renin, whatever.
Yes. Mm-hmm.
You wrote it out for me, but I can't find that.
Yeah, I put it in some other thing for some reason. Let's see if I can find it. Oh, you know what? I also see like a thing where I talked about osmotic pressure and
Yeah, you did.
stuff
Mm-hmm.
with pi is equal to I m r t, and then I have hydrostatic versus osmotic pressure. What was the thing that you were asking? The kidney with blood volume and stuff.
The angiotensin, yeah.
Yeah,
Because I
yeah.
know you have a decrease in blood volume due to like dehydration
Correct.
or something like that.
Mm-hmm.
I just forgot. I know I just need to look at the pathway to remember certain stuff.
Yeah, I'm trying
A
to.
few things I just need to like. I know the surface level content for it, but I need to like go in
Yeah.
depth so I don't miss stupid questions. Like with SN1 and SN2, like I know which one it prefers. Like SN1 would prefer tertiary, then secondary, primary, but I have to go back in the notes that you wrote for me to look over like which
Mm-hmm.
one likes a strong nucleophile and all of that stuff.
Oh, yeah. Okay. Yeah. Let's see what you think, even without looking at all that, because you can reason it out.
Oh, you think so?
Well, yeah,
um,
that's even more important.
so SN1, I know
So why is the tertiary favored?
because SN1 is the one that forms a carbocation.
All right.
So if it forms a carbocation, then it needs to
Oh,
if
so what type of carbocation is most stable?
tertiary.
Exactly, right? Because it has that charge spread out across a lot of stuff. Why is it
Yes,
why is it not favored for SN2?
because SN2 does the whole backside attack and it
Yeah.
happens
So
one
if you have
step.
all that stuff in the way, it's going to be like, eh.
Yeah, it can't do it.
Yeah.
Okay.
So
Okay.
and then okay, what about nucleophile strength?
So SN1 would prefer a greater nucleophile strength, a nucleophile with more strength because it attacks nucleophile. I know it's negative. Nucleus loving. I know it's negative, but I don't know why SN1 would prefer a strong nucleophile.
Would it be SN1?
Or is that SN2? I don't know.
So
Oh, it would be SN2 because you want to make that a good leaving group. So you'll attack, right? No?
so
I forgot.
okay. So basically so I'm trying to look for where I wrote it, but it doesn't really matter.
Hold up too.
Um but yes, the thing with the stronger nucleophile will basically just go right at it
Mm-hmm.
compared to something that is not that strong of a nucleophile.
Mm-hmm.
So, geez, where the okay, let's see. Oh, for some reason I named it nothing. So, okay, so first of all, if so in the thing that I wrote, you ask yourself, does the nucleophile attack first or does the leaving group leave first, right?
Yep.
So if a nucleophile attacks first, it's going to be pretty strong, right?
Yes.
Yeah. So a strong nucleophile will, if that attacks first, is going to be SN1 or SN2.
SN2.
Yes. Because it just goes right in there.
Got you.
And, okay. And then SN1, it waits, right? For the leaving group to leave first. So the nucleophile isn't going to be strong because it's just going to be waiting.
Got you. Okay.
Yeah. And,
Okay.
yeah, okay. So, yeah.
There's just little stuff. I don't know. I think I'm just psyching myself out. I know a lot, but I think I'm just psyching myself out because I do not want to have to take this again.
Yeah, just, it's good to know, but it's better to know why.
Yeah. Okay.
Because then if you don't know, you can reason it out, right?
Mm-hmm. And for psych soc, for some reason, I just cannot get above like a 126.
Yeah, I think we should go through the psych soc stuff.
Yeah. So, okay, little stuff. My problem with psych soc is, well, it's not even just psych soc, but a lot of it is with psych soc is me being between two answers because I know this. I know pre-operational, that stuff. Like I know egocentrism is with the pre-operational, but I guess while I was taking this, I forgot when I was reading this, I was reading it as what it said cognitive limitation. So I was like, I know for 12 years old and plus, that's when they have an understanding of conservation. So that's why I chose B.
So what's meant by conservation?
Like science stuff, right?
Kind of. It means like, if I take this and put it into a thinner glass, it'll be like a higher level. but it's the same amount of fluid.
Okay.
So that's what's meant by conservation. So at a certain age, so like whenever they talk about ages and stuff and cognitive limitations, they're talking about like with Piaget and like, you know, at a different age they'll achieve like a sense of they'll develop in those terms. Like one of the first things is like object permanence.
I know that's that's the first stage that deals with
Yeah.
whatever.
It's like with my like really young cousin, I used to like show him something and then like move it away from him. So object permanence, if you don't have that, if you see something in front of your eyes and it's no longer in front of your eyes, it no longer exists in the brain. Cuz you know, they're young.
I think for this, I had it memorized last time I was studying. But I just this one was a memorization too, because from ages 2 to 7 they're in the pre-operational stage, and that's egocentrism. From 0 to 2 it's sensory motor, and that's object permanence. And it's formal operational, and then it's concrete operational, right, or something, or it's concrete then formal. But,
so the last thing that they gain is that essential empathy, which is the opposite of egocentrism.
And egocentrism is in which?
So like they basically, that's the last thing that they essentially learn to outgrow.
Okay.
So because like if you're pure egocentric, right, you only care about yourself, and empathy is the opposite of that. Okay. Yeah, so that's why they let's see, they did like some type of study or test or something to see perspective taking skills, empathy, personal distress when witnessing other people's pain, etc. Right? So those are basically like empathetic things. So if they did it with 5-year-olds, you're not going to be able to do have those empathetic qualities.
Okay.
Because they're too young. Let's see. Interpersonal attraction. Which variable is the least likely to predict whether two participants will select each other for a coalition in study 2? Study 2 focused on... Okay. Coalition as opposed to a war game, right? So that means that they're basically... Like a coalition, means you're working together. So basically,
and that's why I thought D would, because neuroticism is like somebody just thinking of themselves type thing, right?
Oh no, because that's like ocean traits.
Yeah, I know it's the big 5. It's
yeah. So neuroticism is, those traits are not going to be really related to empathy and stuff like that. Okay. Like it doesn't mean that they'll have less or more. It just is a behavioral trait that is associated with like worrying about things, And
that's what
I would say that pre-meds are very are very neurotic because you have to worry about things because there's a lot of things you have to do.
Oh, that's what I'm going to... Okay, so that's why I chose this, though, because I was like interpersonal attract, but I was like, if it's somebody that's like down all the time and stuff, they wouldn't want to form a coalition with them. They want people that they are... I don't know.
They'll just probably like be really like worried about it throughout it, but they could still, do that. Just yeah. So basically, like least likely to predict, right? So interpersonal attraction, right? And they said that success in the coalition by them selecting each other, which required an understanding of how the other persons felt about each other. So if they're similar, you're able to cross that out because they'll likely, be attracted to each other. Physical attractiveness, yeah. Number of times they've run into each other, right? Means that, they're more likely to have some type of bond or whatever. But, neuroticism wouldn't really have much to do with it. agreeableness, yeah, and extroversion, yeah. Those things could have a good. Those things could be good predictors of whether they'll be good at working together.
Okay.
And then disagreeableness, yeah. So
I hate this. Like, I feel like with like CP and BB,
Mhm.
mostly CP. That's why that's my favorite section. I do the best on that one because when
Nice.
you learn, you can apply it to other stuff. And
Yep.
I mean, yeah, here too with definitions, but it's always different scenarios. So then I always confuse it, and
Mhm.
I'm not good at memorizing stuff. Like that's my worst thing.
Mm-hmm.
But the crust.
Have you ever taken like one of those tests? An ocean
What?
test?
What type of test?
Oh, like ocean to look at those characteristics?
Oh no, I probably should.
They're pretty cool.
Okay. Okay.
I tested very low for neuroticism.
Man, I feel like you're just so carefree and just be doing your own thing.
But
I
I
wish.
tested low
I feel
for
like I was
conscientiousness, which is even so in one of the Berkeley Review psych books,
Mhm.
they basically found that it was like a better indicator of success than like IQ. Because think about it. Because conscientiousness means like you're organized.
Well, I would probably test low for that too.
No, you seem pretty organized. I just go like, just show it to me. I'll do it. But yeah.
Okay, so this next one, this always confused me. I just thought, so the way I was looking at this, I know a valid validity is like, is the test testing what it's supposed to. So I chose A because I was like, if you have a positive correlation between empathy and perspective, then it's not testing it because they said that they hypothesized that they're two separate skills.
Yeah,
So-
that was a hypothesis, and then they did the studies to kind of see if this was true, right?
Yeah, so I was like, if there's a positive correlation, that means that they are not two separate skills.
Oh,
That's
well, so like the beginning, it's like they're seeing like, okay, is perspective taking and empathy, are they going to be correlated, right? And then they did study 1 and study 2, and then at the end, they basically give you the results, right? And they basically looked at perspective taking skills, empathy, personal distress when witnessing someone else's pain, and fantasy perspective taking, where you essentially put yourself in someone else's shoes. And it says higher scores on these questionnaires indicated higher levels of perspective taking skills, right? In addition to empathy, personal distress, and fantasy perspective taking. So all those things were like essentially positively correlated with empathy, right? So okay. Oh, so the last thing you highlighted, everything before that?
Oh, okay.
Yeah, because you see like they had to answer, these questionnaires that look at perspective taking, empathy, etc. And then they said higher scores on these, characteristics indicated higher levels of perspective taking skills and empathy and all that stuff, right? Okay, so which of the findings, if true, right, would suggest that the empathy questionnaire is not a valid measure? So let's see. Positive correlation between scores on the empathy questionnaire and the perspective taking skills questionnaire, right? Because they essentially were trying to see that, if you are better at being able to take the perspective of someone else, that you should have better empathy. And they found that was true.
Okay.
And yeah.
Okay. No, go ahead.
And then let's see. I'm going to go to C. A positive correlation between scores on the empathy questionnaire and the fantasy perspective. So that's another thing that they tested, right? The fantasy perspective taking. And that, they found was correlated with higher levels of all those things, right? And then D says no correlation between the scores on an empathy questionnaire and the amount of money won. So, I mean, that it seems like all these things are in, they have a money element to it. but it
Mhm.
doesn't seem like that, had any.
So basically,
Yep.
the answer is in the passage. So right here.
Yeah.
Okay.
So if one of these is true, right? It would it's saying like which one, if true, would suggest that questionnaire is not a good measure. And
Okay.
so I see a negative correlation between the empathy scores on the empathy questionnaire and the personal distress questionnaire.
Because they said that it was.
So like all of these things
They said
are
it was.
positively correlated, right?
Yeah.
With with all these levels of whatever they're testing.
Hmm.
So
Okay.
B is the only one that says that there's a negative correlation.
Got you.
Which of the following hypothetical findings would best support the researcher's hypothesis? Oh, interesting. Thicker cortexes show improved performance in both studies. Participants who have impairments in recognizing faces poorly. Damage to the language centers. So these are all things that, we're trying to see if this empathy thing is related to, what was it? It was like perspective taking or something like that. Was it? Something like that,
Yeah.
right? So basically, what would best support it? So far, I don't see anything that's related to that. Let's see. Participants with damage to a specific region of the cortex have difficulty inferring others' feelings, right?
Mm-hmm.
That means that people with that, damage to that part of the brain, they can't guess how other people feel.
Damage to a specific region.
See, they have difficulty inferring other people's feelings.
Uh-huh.
So if someone has a hard time being able to guess how another person feels,
Mm-hmm.
how good do you think their empathy is going to be?
Low.
Yep.
But how does that have? What does that have to do with them? Oh, the hypothesis.
Because the hypothesis, right, is essentially trying to see which of these characteristics, essentially on the top it tells you if they're trying to see if empathy is associated with perspective taking, right?
Mm-hmm.
You see how it says hypothesize that perspective taking and empathy are two separate skills, right?
Mm-hmm.
And then they made these studies to evaluate perspective taking. So study 1 focused on perspective taking, right? Study 2
Yeah.
focused on empathy, and then they're trying to see if there is a if there's any type of a connection between the two, right?
Mm-hmm.
So so through A through D, right? So A says people who have thicker cortexes show improved performance in both studies. We want to see if there's improvement in one, there'll be, improvement in the other, or vice versa. If it says, so A is saying it's just improvement in both, that doesn't really show us anything, right? Because
You're trying to see them separately.
exactly.
Okay.
And then B says people who can't recognize faces well, that's not really, something that they're really testing, right?
Mm-hmm.
And by the way, if you wanted to know, some people have a kind of like a impairment in the part of the brain called the fusiform gyrus, which means that they can't really recognize faces.
Mm-hmm. I think I actually heard of that.
Mm-hmm.
Okay.
Yeah. And then C, it says just damage to language centers, which means that they have difficulty understanding the rules.
Mm.
But,
But
that doesn't mean...
this
Yeah.
isn't testing what they're asking.
Yeah. Because, I'm sure if they learn the rules, they'll still, they'll perform, as expected. But D is the only one that says some part of the brain that means that they can't understand how other people feel, aka they have they can't really take the other person's perspective well.
Yeah, that makes sense.
Yeah, like in psychopaths and stuff like that.
Okay. What did I put for this? So I put B because I know I thought that's what the whole arousal thing, but I guess that's just with the whole social facilitation stuff.
Oh, this is a different one. Let me check it out.
Huh?
Oh, this is different. Let me check it out. Let me see the top for a sec.
Oh.
All right. So study 1 seems to show that strong emotional reaction is positively correlated with,
Detailed reports.
detailed memories. So their memories are pretty accurate. And, over time, right?
Mm-hmm.
Like they did it like 1 month after and then more than 1 month after, right?
Mm-hmm.
All right, now, day after it happened and then 2.5 years later, right? And let me guess. The consistency sucked. Let's see. Yeah. 25% were wrong about the key details. So, let's see. Omission errors. But many were intrusions, which were details that were consistent with the situation but missing from the initial report. So that means essentially that the first time that they were told to talk about that disaster, like a day after it happened, right? There were some details that were not mentioned, but 2.5 years later, when they tried to remember that disaster that they witnessed or something or heard about, that they added some details that were not there at first.
Mm-hmm. Okay.
Oh, and then there's study 3 that says... So, okay, now this is not about some momentous newsworthy event. So, they used a sequence of slides involving a violent car accident, and they happened to remember the more central aspects rather than the peripheral details.
Okay.
Okay, so now the finding from study 3 regarding the differential aspect of emotional arousal on memory for central and peripheral details is best explained by which mechanism? Increasing emotional arousal, let's see, causes a restriction of the focus of attention, improves memory but only to an optimal level of arousal, impairs the encoding of peripheral details. So I could see C being something that could be right. Let's see. Enhances the retrieval of encoded central details. So, alright. So basically, study 3 is essentially showing that well, it essentially is showing just that people who are shown some type of, violent car accident, they remember more of they remember less of the extraneous details.
Mm-hmm.
So, this is kind of, I don't know. I'm thinking of a real life example, which is I think you were too young for. Well, let's see. You, generally speaking, in psych-soc, memories start from what age? What would be the earliest memory you could remember? Generally, what age?
Toddler years.
What's that?
Toddler years. 5.
So, the earliest would be 3.5?
Yeah, that's what I was about to say because I said toddler, but then I switched it.
Oh, yeah. I don't even necessarily know what age a toddler would be.
Oh, yeah, 2, 3. Yeah.
Okay. So, you were probably 3.5 or less than, Wait. No, you were like, yeah, maybe. For like 9/11?
When did that happen? 2001.
Yeah. So you may not like remember it as much because you were
I
too
was
young. Yeah.
Yeah.
So like I was like, you know, whatever, like 12, I think.
Uh-huh.
Yeah, so that's something that I remember very much in the sense that, like, for study one, it says, like, famous political assassination, right? And the reports of the memory included details about where they were, what they were doing, who brought them news. So, like, 9/11 for me, I remember, like, I was, like, in lunch in 8th grade, and, you know, we heard it on loudspeaker. So, remember all those, so, like, I remember all those types of things.
Yeah.
Now, that's what they did in like study one, right? And it's consistent over time because I still remember those same details. Now, study three kind of showed something that, like, basically, like, essentially just happened. It's not newsworthy. It's not in the news. So, what parts do you remember? So, they essentially basically saw that they remembered more things like the central aspects, like the car accident itself, rather than those peripheral details. Because, like, you know, and the contrast to that would be, like, my memory of 9/11, which is more on the peripheral stuff, like where I was, those types of details.
I guess what I was confused about is
Did you
that they
pick
said
C?
increasing emotional arousal.
Mm-hmm.
So how would I know that this was them increasing emotional arousal? What do they mean by that?
Oh, okay. So this is because, well, we know it's an emotional thing, right? Because it says not all emotional memories involve learning about, like, these newsworthy events. Like, a newsworthy event would be, like, you know, 9/11, for instance. So this is just an example of emotions still playing a role. And it just says that they remember, like, the central aspects more than the peripheral aspects. So what I would, you know, choose would be either A or C. I'm wondering if you chose C.
No, I chose B. But I was thinking of the whole social facilitation stuff. How it says you can only do stuff up to a certain thing of arousal, and once you hit that arousal,
Oh,
you're
you're thinking of, yeah, like Yerkes-Dodson law?
yeah,
Mm-hmm. Yeah, so that's like when performing a skilled, like an activity that requires skill.
yeah,
Like, remember that passage that we did with, like, remember, like, you know, observer that's like a friend, observer that's a stranger, and then, like, remembering, like, or saying something with accuracy and speed.
yeah.
Yeah, so that's for, like, a skill, like, doing, like, a skilled task.
Got you.
Yeah, so that's the Yerkes-Dodson kind of thing. But this is just saying, you know, so basically we know that from study 3 that the central aspect of the event is remembered more clearly than the peripheral details. So that's why I would, so, like, B, like, you know, B is saying improving memory generally speaking, but we want to differentiate between the types of memory, like if it's on the central aspect or the peripheral aspect. And
And I guess with C, because it says encoding, and I looked up what encoding is. It's the initial learning of information.
yeah,
So they
so
didn't say
encoding
that
is when you get it into your like you encode it into your memory banks.
Yeah, so yeah, learning it, right, for the first time.
Yeah. Okay, so I could see how D could also work because I was looking at A, C. So okay, let's say A, C, and D, right? Because okay, so A says that. Okay, so
Wait, what time do you have to meet Tamia? Is it 5?
Oh, I told her that since we started at 5, so like at 5:20.
Okay, cool.
So yeah, so let's see. Okay, so basically A is saying that a restriction of the focus of attention, which means that your focus is just on the central aspects and not the peripheral aspects. C is saying impairs the encoding of peripheral details, which can also result in you remembering more of the central aspects. D is saying enhances the retrieval of encoded central details, which is also saying the same thing, right? So that's what makes it tough, because all three of those choices are possible,
But I
right?
guess since, like you said, C and D are basically saying the same thing, they can't be right.
Let's see. Impairs the. Well, if you enhance one, I mean, okay. So how can we separate the nuances between A, C, and D, right?
Mm-hmm.
Okay.
I think it goes back to what they stated specifically in the passage, because they said remembered more central aspects and fewer peripheral details, for example, the street. But they didn't say that them learning that information, like the encoding of the peripheral details, were fewer. They just said how they remembered it. It was fewer peripheral details. So they didn't have a problem encoding the information. They just encoded less, I guess.
Yeah. So let's say that. Okay. So if it impaired the encoding of peripheral details, those are pretty much not remembered from the get-go. If it enhances the retrieval of encoded central details. All right. Let's see. I'm gonna look at what they're saying, because I want to separate the encoding aspect. It says that person will notice information that elicits arousal but fail to process other information. Okay. Let me see the top. Okay. All right, I think I see. So study 1 and 2 are essentially events associated with a high level of emotional arousal that are momentous and newsworthy, right? So they found that basically peripheral and you know what? Okay, I'm gonna just screenshot this and come back to it. I have an idea, but I'm not certain on it.
There you go.
Oh, okay, that's better. Here, one sec. Because what I think is that yeah, I'll have to come back to this one for a better explanation. I mean, I have an idea, but I want to be more certain about it.
Okay. So this one. So
do you remember how sleep worked?
yeah, so I know it's for N1, N2, N3, and RAM N3, something like that. It was on my mem card and I memorized it, but now I forgot it. This is why I hate psychology so much, because it's just freaking memorization.
Yeah, but you can learn about learning from it.
Because
they're learning about memorization and how it works.
Yeah, if I had more time, okay, cool. But I don't have that time right now, so I just have to memorize because I have a few days left.
Oh yeah. So essentially, right? Okay, so they're so just okay. So let's see. How can I?
So the sleep cycle is N1, N2, N3, N2, RAM, N2.
Yeah.
It's the order.
So all right. What's the one where you're sleeping?
Non-RAM. So the everything.
Oh wait,
else...
no. Obviously, what? That was a horrible question. What's the one where? All right. So sorry. I said.
So REM is when you're not really sleeping. I know that's when you have
So, do you see that right there?
No. A little bit. Is that the word stuff? Because I just memorized it, but they have it in MEM too. Let me show you. It is the same thing you have.
Yeah. So essentially. Oh yeah.
Yeah.
Yeah. So based on the frequency and stuff, you can kind of ascertain, what's happening there, right? With beta and alpha waves, right?
Yes.
Frequency is pretty high, right?
Yeah, so
you're
I
probably
know,
awake, right?
So when they say frequency, okay, because this is my problem when I hear the same term in different different
Contexts?
places, I start to mix it all up. I've heard frequency in physics.
It's the same
different
thing in
times.
all. That's
Okay,
what's gonna help you.
okay, so frequency when it's high,
Yep.
when frequency is high, that means something is moving fast.
Yep.
Okay.
And so these are like EEG readings,
Yes.
electrical, basically the electrical activity of her brain, right?
Something gram, yeah.
Yeah, yeah. And so if it's fast, right, you're
Mm-hmm.
probably awake, right?
Uh-huh.
Good. And as you sleep, it gets slower, right?
Yep.
And and then the stages get deeper.
Mm-hmm.
So
So
like,
question,
yes,
is amplitude inversely proportional to frequency?
wavelength.
Amplitude is inversely proportional to wavelength?
No. Sorry. Uh, wavelength is inversely proportional to frequency.
Yes. So what's the
Amplitude is
relationship?
amplitude is independent. Amplitude is just how high or low it is. That's a different kind of thing. But frequency is essentially, think of it like this: how often does this thing happen, right? If it happens more often, it's more frequent, right?
Mm-hmm.
And if it happens very, very frequently, wavelength, which is the length of one wave, if it happens super frequency, the wavelength's going to be super small.
Yes.
Yeah. So, okay. Now let's check it out. So, rapid eye movement. Yep.
Trying to make sense of this, I know each REM time, you get more REM in the last, each subsequent sleep cycle has more REM, such that the last cycle has the most REM. So if they if they keep waking the person up when they're in REM sleep, and the following night the sleep is uninterrupted, they would have more REM because their eyes are, yeah, they're just not being interrupted.
Oh, you're saying, well, so, oh, you mean in terms, okay. So let's look at this problem. But let me just ask you, what would the EEG activity look like of someone in REM sleep?
Wouldn't that be beta?
Yeah, it'll be
Beta.
close to beta or alpha. It'll look like you're awake. So, like,
Yeah.
that's
So it
basically
would
when
be,
your body is essentially paralyzed, but your brain, you're dreaming. So your brain is pretending like, what's that?
it's high frequency.
Mm-hmm. Because you're dreaming, you're acting like, you're in real life.
Mm-hmm.
You would be moving around like you're in real life, but your brain, shuts off the rest of your body.
Mm-hmm.
So, that's why it's rapid eye movement.
Mm-hmm.
Yeah, and REM is interspersed between the cycles of non-REM sleep. So, okay, every time a volunteer in a sleep study begins to exhibit rapid eye movements, the experimenter wakes them up. I would hate that. On the following night, when his or her sleep is uninterrupted, the person will most likely... Okay, yes. So, this is basically like... What is it called? It's like making up for it. There's like a term for it. Oh, yeah, REM rebound. That's what it's called.
Okay. So, okay, just to say it again. So when you have high frequency, that means high speed. High is what's happening fast.
Like your electrical activity of your brain. So thinking, dreaming. It would be cool to like take the MCAT and have an EEG running at the same time.
Oof. That would be funny.
Mm-hmm.
The brain is electrical activity and brain is moving.
Mm-hmm.
So that's equal to like REM almost.
Yeah, so that's why REM is called paradoxical sleep, because your arousal levels reach that of wakefulness, but your body and your muscles are paralyzed.
So your body.
Mm-hmm.
You said, say that one more time.
So your
Sorry.
So your body / muscles are paralyzed. And I can like scan this for you. This is like, when I first, this is like before I got a tablet, so I drew everything out. Like, that's a nice brain, right?
Mm-hmm.
You see it?
Oh, wow.
Yep.
Wow. Oh my God, that looks so good. You should see my drawings. Okay, so
That's the
body and
ear.
muscles paralyzed, but wow, that looks so good. Is that the kidneys?
Oh no.
What's that?
That's
Oh,
the ear,
ears?
and that's the inner
Yeah.
ear. Yep.
I need to also look over ear stuff. I always miss those ears and eyes.
And
But you
and you said
said,
eyes.
yeah, like I always forget which one does which, like cornea,
Like that.
lens. Yeah, I always forget which. I know lens bend the light or something like that, but I forget the other ones like retina, cornea. I need to look over that.
Oh yeah, the cornea is the thing that causes the light to refract. And the lens can go like can be bigger and smaller. It just helps well, it helps control the refraction essentially. But I'll send you some. I'll scan these.
A lot of things to go more in depth with. Okay, but you said body/muscles are paralyzed, but something.
Yes, but your brain is acting as if it's awake. Oh yeah, I even have like the angiotensin like blood volume thing over
I
here.
think that's what you sent me a picture of,
That's a
or
pretty good kidney, right?
yeah, it is. But yeah, this is kind of off topic, but
Mhm.
when it comes to, I always confuse the sodium potassium pump with action potential. So I know the sodium potassium pump is three sodium out, two potassium in.
Mhm.
But what is that that's what deals with the hyperpolarization, depolarization and stuff?
The sodium potassium pump essentially keeps the you can kind of think of them as like the leakage kind of pumps. It just keeps it at it keeps this differential between the concentration within and outside. So it keeps it so the inside is kept at a negative overall, potential.
Mm.
Yeah. Now there's the sodium potassium ATPase.
Yes, that's what I was talking about.
Yeah, that's the thing that pumps out 3 sodiums and pumps in 2 potassiums.
Okay. So what's the difference like between those two?
Oh, okay. So basically, inside of the cell, like the neuron, right?
Mhm.
The concentration of sodium is like 10 to 15 millimoles, whereas outside the cell, it's like 10 times that.
Okay.
And it's vice versa for potassium.
Okay, so potassium, it's 10 times.
So basically, potassium, it's 120 to 140 millimolars inside of the cell.
Okay.
And outside of the cell, it's 5 millimolar.
So
Yep.
I just need to look over that.
So, like, think about it. If a sodium pump, like a regular one, right, opens up, which direction will the sodium flow?
If a sodium pump opens up,
Yeah,
it will
like a
be
regular. What's that?
inside.
Yeah, right? Because there's much more outside than inside.
Mm.
And it's positively charged. So, what'll happen to the charge of the inside of that neuron?
It'll be more positive.
Exactly. So, that's what depolarization is.
Oh, so when you talking about action potential,
Mm-hmm.
it deals with bringing sodium inside and
Mm-hmm.
potassium outside.
Yeah, so the first thing that happens is the sodium like voltage gated channels open quickly,
Hmm.
causing a crap ton of sodium to enter inside of the cell, which causes that membrane potential to go from like -80 to
To
like
negative
positive 40 or
35.
something. Yeah, pretty much. That's if you do
Positive
there's like negative 70 to positive 35, or,
Mhm.
in my notes I have like negative 80 to positive 40.
Mhm.
And by the end, like as it reaches that top, the sodium channel closes.
Okay. So
Alright.
what's the sodium potassium ATPA score then?
Oh, that's just the thing that maintains the so it pumps out 3 sodiums and takes in 2 potassiums, and it just maintains uh, that differential. Because if it didn't do that, right, it should
Mhm.
just be in equilibrium. It should be the same
So
inside and outside.
both of these are happening at the same time.
What's that? The
These are happening at the same time to generate an action potential.
oh no. So well, the AT the okay, the regular one that maintains the resting membrane potential, that's happening all the time.
Okay.
But when an action potential happens, that's when we're talking about different ones. So that's when, the sodium voltage gated channel opens up, causes a sodium influx, which causes the membrane potential to shoot up. And it
Okay.
opens and
So
closes quickly. So by the time it reaches the top, the sodium channel is already closed. But that is when the potassium channel opens up. And it opens up slowly. So when the potassium thing opens up, what'll happen? Think about
um,
amount inside and outside.
yeah, potassium will go outside.
Exactly. So like another word is efflux. So the
Mhm.
potassium goes outside. And potassium is positively charged, so when it, goes outside, what happens to the charge?
Positive.
Positive, it leaves it, right? So it goes back. So like when the potassium pump opens, the
Mm-hmm.
positively charged potassium leaves, right?
So you're asking what happens to the neuron?
Yeah,
It becomes more negative, right?
exactly. So that's when you have it go down. And since it's slow compared to the sodium one, that's when you have hyperpolarization. I mean, you have repolarization first, but it overshoots it a bit because it's slow.
Okay, so that's where I'm confused at.
Uh huh.
This whole thing, the pump is resting membrane potential, but the action potential is that the ATPase?
Oh no, the action potential are different. Those are the voltage gated ones.
I'm so confused.
Okay, so think
Okay,
about it in
what's the
terms of
ATPase?
diffusion, right? If you
Uh-huh.
go against diffusion, it requires energy, right?
Mm-hmm.
So if it's an ATPase, it's going to be doing active transport. It's going to be going against diffusion.
So what does the ATPase deal with is what I'm asking.
It deals with keeping the neuron at a negative potential. It
But
keeps
okay,
it
so what?
it
Okay,
keeps it
I think.
negative,
Uh-huh.
which it doesn't want to be normally, because normally it just wants to be in equilibrium with its surroundings, right? So
Mm-hmm.
the ATPase just keeps it at that resting membrane potential of like negative 70.
And the action potential deals with the pump.
Yeah, those are voltage gated, meaning that um, essentially when a change in voltage happens, then things can go up or down. Yeah. Or I'm sorry, things can open or close.
Okay.
And yeah, and they're essentially just, following, diffusion. So no energy is required. Anything with ATPase requires energy, which means it goes against diffusion, which means it goes not from high to low, but low to high.
Okay.
So the sodium potassium ATPase, it pumps out 3 sodiums and it pumps in 2 potassiums. And since there's a lot more potassium inside
Mm-hmm.
and a lot more sodium outside, in order for it to pump sodium outside, sodium goes from low to high, right?
Mm-hmm.
And in order for it to pump potassium inside, potassium concentration goes from low to high as well, right?
Yeah.
And if it's going from low to high, it's not diffusion, right? It requires energy because that's not how it would normally, naturally flow.
Got you.
Yeah.
Okay. Okay. Okay, so I'll get this one. So this one I always get I know social capital deals with like who you know, stuff like that. But and I changed my answer. I put C first, but the reason I chose occupational status is because I was thinking about that deals with how much money they make.
Let's see. Test the hypothesis that controlling for socioeconomic status should reduce racial differences in stress. Which data would a researcher be least likely to include in an aggregate measure of socioeconomic status?
Like, why would they care if they fired or not?
Well. Occupational status is like basically like, are you working? Are you not working? Where do you work? Right. So wouldn't that would be something that would be in a measure for socioeconomic status, right?
Yes.
And
the way I was thinking
least,
is, why would they care if you're fired or not?
Well, so okay, socioeconomic status, right? If I'm fired, right, that affects my socioeconomic status. Because I'm not making money. Yep. So like income sources, educational attainment, right?
Mm-hmm.
Social capital is like more along the lines of like, it's not what you know, it's who you know, and getting connections and stuff like that. But that's not really something that that's not like, if you know more people, it doesn't necessarily mean that you make more money, right?
Yep.
But yeah. Socially, yeah.
I was thinking too deep into.
Mm-hmm. But yeah. Imagine, someone who makes a lot of money gets fired. Socioeconomic status changes, right?
Yep. Yeah, this one threw me because I thought it was a positive correlation because people in lower socioeconomic positions face more. If you're in a lower socioeconomic, you face more.
Yeah. More stressors, right?
Oh, that's off.
But they're saying, yeah. Wait, sorry.
No, go ahead.
Oh yeah. So yeah. So okay. If you have a high socioeconomic status, there's going to be a less exposure to stress, right?
Mm-hmm.
Yep. Yeah. So you had the right idea, just the other way around.
And then how the heck are you supposed to know if it's negative? Like, they have two negatives and two positives. Like, both A and B are both negative correlation. They don't tell you how much they relate.
Oh, because it says disproportionate amount. So that generally means that they face a lot more than what you would expect. Like, it's not a proportionate, like, in the sense of, like, let's say your socioeconomic, let's say the amount you make is 100K and then you make 200K. Does it mean that your exposure to stressors gets cut in half? So that would be if it's proportionate, right? But like, let's say you're making like 20K, right? And you can't even afford to, go to the doctor. You can't afford books. You can't afford MCAT tutoring, right? Then your exposure to stressors, it's not just going to be like, what did I say? I said 40K? That's not going to be like a quarter, or sorry, 2/5 of if you made 100K. It's going to be a lot more. You're going to experience a lot more. So that's what's meant by disproportionate. So so I should have used better numbers. Like, if you're making 20K a year compared to if you're making 100K a year, right? 20K times 5 is 100. So does that mean that the amount of stress that someone making 20K is 1/5 that of someone who's making 100K? That's if it was proportionate, but it's disproportionate because someone making 100K has like 0% of the stress that someone making 20K does. Because things compound, right?
Mm-hmm.
So in terms of like negative, it makes sense, but it's going to be a large amount.
Okay.
That's what the disproportionate part means.
Got you. Okay, so this one I thought I was right because it's talking about discrimination and
Mm-hmm.
blah blah blah. So that's why I put socioeconomic gradient in health.
Well, okay, so this is talking about talking about prejudice and discrimination, right?
Mm-hmm.
So, you can have a lot of money, but they're talking about but you're still going to experience, some prejudice and discrimination, right?
Why?
Because I don't know, people suck.
Oh, is that what it says?
Oh yeah, because they're just trying to like this passage isn't really talking much about socioeconomic factors. It's talking about prejudice and discrimination,
Mm-hmm.
right?
But
And
that social identity threw me off. And what do they mean? Like I know psychosocial stressors would be the prejudice and discrimination, but what is I didn't get the social identity part. That's why I didn't choose that one.
let's see. Oh yeah, so that's saying exposure to some psychosocial stressors will be attributed to social identity. So like a social identity is without the economic aspect of it. So like this is kind of telling you that for instance that well like
So
yeah
it would be like African American or
like
Hispanic.
yeah, like if I can use like a real world example, it would be like friends of mine who are women who are doctors.
Mm-hmm.
Their socioeconomic status is great. However, their social identity involves them being a woman, and so when patients come see them, they think that they're a nurse or something.
Got you.
So, and then if you're like black or Hispanic, there could be some additional things where they're I don't know racist because just prejudice and discrimination like that is about color and things involving social identity and money. It doesn't really fix that, right?
Yeah. Okay, that makes sense. I crossed out the right answer. What did I choose? I chose A.
Let's see. Conditioning principles. Oh, that's like, okay. To explain the progression from alcohol experimentation in adolescence to alcohol dependence in adulthood. So it seems like sensation seeking, which is something I'm like. Let's see.
No, I actually read it from. It said something Oh yeah, right here.
Mm-hmm.
Dependence develops later in life when alcohol is consumed to alleviate negative emotions.
Mm-hmm. Yeah. So this is essentially saying that some adolescents, right, they're conditioning themselves to essentially self-medicate, negative emotions with alcohol. So they condition themselves to associate positive emotions with alcohol.
Okay.
So now
Because the way I was looking at it, I was like, the negative reinforcement for that one is what threw me off because I was like, they're adding something which is alcohol to decrease.
So if they're adding something, it'll be a positive, right?
Yeah, so that's why I took off because it says later use is maintained by negative reinforcement. I thought it would be positive punishment because they're adding alcohol to take away negative
I see what you're
emotion.
saying. Okay, so check this out. So it starts off with adding alcohol, right, to feel good, right? Because it says, for adolescents who experiment with alcohol in their peer groups, sensation-seeking behaviors may be associated with alcohol's positive effects on mood, right?
Mm-hmm.
But then dependence later develops in life when it's to alleviate negative emotions. So, essentially, first, they're creating a positive association with alcohol and feeling good, right?
Mm-hmm.
And then later, it's like they need it to not feel bad. Or if they feel bad, that's when they drink it. So think of it as a dependence, right?
Yeah, but I still don't get how that's negative reinforcement.
Let's see.
I thought negative reinforcement is when you take away something to increase a certain behavior.
Mm-hmm.
So which behavior are they trying to increase?
Oh, I see. So I'm sorry. I should have said this. It's not the positive and negative isn't alcohol. The positive and negative are the emotional effects.
Got you.
So it starts off with alcohol giving them a good feeling.
Okay.
And then it later turns into alcohol, I need it so I don't feel as bad. So like imagine, like taking something to feel good and then that's okay. Why not, right? But then later on, if you feel bad and your only response or your only way to cope with that is to take alcohol to make you feel less bad, that's when it becomes a dependency.
Alleviate negative emotions. That's the part I still don't get it. Even if it's talking about the emotional state, I feel like what are they trying to reinforce? Happiness?
Mm-hmm. Yeah, emotional, like mood, essentially. Think of it as mood.
So they take away their negative emotions to feel happier.
Yeah, maybe not necessarily happier, but to not feel as bad. So, yeah, let me think of like another analogy, perhaps. So okay, let's say you get like a 526 on your MCAT.
Mm-hmm.
You're gonna feel good, right?
Yeah.
All right. Then let's say that you're like me and you get. So like one way is like 526. I feel good, but another way is 526. It's not a 528. So I feel bad.
Okay.
So like it's like it's like a same score, right?
Mm-hmm.
And it can make you feel really good, but it's a dependence when if it's not that that it's just something that'll make you feel less bad instead of good.
Okay. This is confusing, but okay. This one, I put a.
Let's see. This one. Lack of support for the predictive models of prejudice and discrimination is best explained by which statement? Lack of support for the predictive models for prejudice and discrimination. Final
Like the last
paragraph.
page.
Okay. Oh, because they're saying, however, patterns generally fail to fail to support this prediction. Let's see. Additional risk factors might confound. Okay. Discrimination. Okay. All right. So, what could be some reasons, or what can be some examples of there not being support for this predictive model?
Is this the predictive model right here where it says
Yeah.
some theoretical models predict the exposure to prejudice and discrimination?
Mm-hmm. So, like, if anything that's theoretical does not have any, like, real support, like empirical support for it.
Mm-hmm.
So, and then they say, when they actually tried this out, it failed to support this prediction, right? So, because they're saying, like, if you experience more prejudice and discrimination, it should mean that your rates of alcohol consumption should increase. However, African Americans and Hispanic Americans who are exposed to more prejudice and discrimination have lower rates of alcohol consumption. So, why did that, theoretical predictive model fail? Like, what could be an example that could have made it fail?
Mm-hmm. Yeah, I mean, if you ask it that way, it makes sense. I just didn't know what I didn't get it. Like, I didn't get it. The question.
Yeah. So it just says, final paragraph, predictive models, right? And then it says predict, right? And then it says, these patterns generally fail to support this prediction. So they're just saying which of these could be an explanation as to why that predictive model failed.
Okay.
So let's see. You said social capital.
Yeah. I just thought if you have a confound variable, I was thinking of confound variables and them messing up the experiment.
Mm-hmm. So yeah, confounding can give you, results that would be all like kind of messed up. But we actually see results that are the opposite. So what could be? So we're gonna look for something that not just like confounds it, but specifically reduces the impact. Because African Americans and Hispanic Americans have lower rates of alcohol consumption, right? So there must be some other type of, so like you're looking at like another risk factor, but it could be like the risk factor, right, could affect their risk, but what about a protective factor, right?
Mm-hmm. Okay.
Yeah. So like for that one, you can look at whichever one would basically reduce their dependence on alcohol.
Okay. So real quick, because I know you gotta go, can we I'll just go over the rest by myself. It's only a few more.
Yeah, why don't you send me, you can send me the ones.
Okay.
And
but
I can, yeah.
When it comes to meeting this week,
Mm-hmm.
so we can meet again. Do you still have your meetings from 3 to 4:45?
I made it so I do that once a week now.
Okay.
So I believe, let's see. So only on a Thursday and Tuesday, I think.
Yeah, so you meet them twice. You do it twice a week?
Oh yeah, it's with 2 people, and I used to do each of them twice a week, so it went from 4 to 2.
Okay.
But yeah, so your thing is Monday through Thursday.
Yeah, so we could meet Thursday.
And what times were they again?
It's from 1 to 3. So I could
Oh,
meet you
okay.
at
Yeah.
5 on Thursday.
Mm-hmm.
So let me text it as we're talking.
Yeah, yeah.
Thursday, 5 to maybe 7. Saturday I'm taking a full in, so Sunday, around the same time, 3 to 5.
Okay.
And then, yeah, next week I'm pretty open.
Yeah, I
So,
can like email you with that.
okay. But yeah, for this week, yeah, Thursday and Sunday.
Yeah, and in the chat I copied and pasted some negative positive reinforcement stuff.
No, yeah, I get it. I just didn't get it. I didn't understand it with their thing because they're not it unless the thing is different for each one. Like if it's alcohol for the first one that they're measuring, then yeah, it makes sense. The person added alcohol to increase feeling good. But if it's the emotions for the second one, then it makes sense. But if they're both alcohol, then it didn't make sense for the negative reinforcement.
Yeah, so in this one, yeah, I guess I can see where so the stimuli in this case is mood essentially instead of alcohol.
But even so, if that's the case, then positive reinforcement doesn't make sense for the first one because what did they?
So like let's say the stimuli is that's added is increase in mood, right? Happiness.
Mm-hmm.
All right? That's
So,
yeah.
mm-hmm.
And then when the stimuli is removed, aka happiness is removed,
Mm-hmm.
that would be negative reinforcement. Any type of reinforcement involves a behavioral increase. So
Yeah. So, but what's
So-
the behavioral increase for the second?
drinking alcohol. The behavior in this case is drinking alcohol, consumption of alcohol, and the stimuli is the effect on the mood, right? So
Okay.
so positive reinforcement would be alcohol causes the stimuli that's added is happiness or like increase in mood.
Mm-hmm.
So that's positive reinforcement, increases the behavior of drinking alcohol. And then later on, the stimuli is removed, aka the happiness is removed. So they feel depressed.
Got
That's
you.
going to be the negative reinforcement because they're going to drink to alleviate those.
Yeah, it makes sense now.
Yeah. So it's
I just
just
didn't know which one
flipping.
was which.
Yeah. Mm-hmm.
Okay. All right. Thank you. So I'll see you on. Well, I'll talk to you on Thursday.
Okay. Yeah, and I'll email you like probably like later today. Okay.
Okay.
To like plan things out.
Okay.
All right. Take care.
You too.
All right.